Almost everyone has used a tape measure at some point. Whether you're hanging a picture frame, building furniture, or tackling a home renovation project, it's one of those tools that seems incredibly simple. Pull out the metal tape, take a measurement, and let it snap back into the case. But have you ever noticed something strange about it? The metal blade isn't flat. Instead, it has a slight curve running along its entire length. It almost looks like a tiny metal gutter. Most people never think twice about it, but that curve is actually one of the most important features of the tool. Without it, tape measures would be far more frustrating to use. They would bend, collapse, and become much less practical. So why exactly are tape measures curved? And who came up with the idea in the first place? Let's find out right here on History of Simple Things. Before tape measures existed, people relied on rulers, folding wooden rules, ropes, chains, and measuring rods. While these worked reasonably well, they weren't always convenient. Long measurements often required bulky tools that were difficult to carry around. In 1868, a British inventor named Alvin J. Fellows patented one of the first spring-retractable tape measures. His design allowed a flexible measuring tape to automatically roll back into a compact case. This made measuring faster and far more portable. Over the following decades, manufacturers improved the design. Steel blades replaced many fabric tapes, springs became more reliable, and engineers discovered that giving the metal blade a curved profile dramatically improved its performance. That small design change transformed the tape measure into the tool we know today. The main reason tape measures are curved is strength. At first glance, the metal blade looks very thin and flimsy. If it were completely flat, it would bend and flop around almost immediately when extended. Try holding a flat strip of paper horizontally. It sags under its own weight. Now gently curve the paper into a shallow arc. Suddenly it becomes much stiffer. The same principle applies to tape measures. Engineers call this increased stiffness structural rigidity. By curving the metal blade across its width, the tape becomes much more resistant to bending. The curve changes how forces are distributed through the metal. Instead of easily folding over, the blade can support itself for a surprisingly long distance. This simple shape allows the tape to extend outward while remaining relatively straight. One of the most useful features of a tape measure is something called standout. Standout refers to how far the blade can extend before it buckles under its own weight. A typical household tape measure may have a standout of around 2 to 3 meters, while professional models can sometimes reach even farther. The curved cross-section is what makes this possible. Imagine trying to measure a room by yourself using a completely flat steel strip. You'd pull it out a short distance and it would instantly fold over. The measurement would become difficult and inaccurate. Because of the curve, however, the blade acts somewhat like a very shallow beam. It remains stable long enough for one person to take measurements without needing someone else to hold the other end. In many ways, the curve is what turns a simple strip of steel into a practical measuring tool. If a curved blade is stronger, you might wonder why manufacturers don't simply make it extremely curved. The answer is balance. A deeper curve would increase stiffness, but it would also create new problems. The tape would become harder to roll into its compact case. It would require a larger housing and a stronger spring mechanism. It could also become less flexible when navigating corners and tight spaces. Engineers therefore choose a curvature that provides the best compromise between strength, flexibility, durability, and ease of storage. Every part of a tape measure is carefully designed around this balance. That's why different tape measures may have slightly different blade shapes depending on their intended use. The curve isn't working alone. Most tape measure blades are made from spring steel, a type of steel that can flex repeatedly without permanently deforming. This material allows the blade to bend when retracted into the case and then return to its original shape when pulled out. Manufacturers often coat the steel with protective finishes to reduce wear, improve visibility, and prevent corrosion. Combined with the curved profile, spring steel creates a blade that is lightweight, durable, and capable of surviving thousands of measuring cycles. If either the material or the shape were changed significantly, the tape measure would lose much of its usefulness. Here's a detail many people notice but few understand. The metal hook at the end of a tape measure is intentionally loose. If you wiggle it with your finger, you'll feel it move slightly back and forth. At first that seems like poor manufacturing, but it's actually a clever accuracy feature. When measuring an outside dimension, such as the length of a board, the hook catches the edge and pulls outward. When measuring an inside dimension, such as the width of a window opening, the hook presses inward against the surface. The amount of movement built into the hook is equal to its own thickness. This allows the tape measure to compensate automatically whether the hook is being pulled or pushed, ensuring the measurement remains accurate in both situations. It's a small engineering trick that most users never notice, yet it helps tape measures deliver reliable measurements day after day. What makes the tape measure fascinating is that its most important feature is also one of its easiest to overlook. That small curve running down the blade isn't decorative. It isn't there because it looks nice. It's a carefully engineered solution to a very practical problem. By adding a shallow arc to a thin strip of steel, designers created a tool that can extend several meters through the air without collapsing. It allows one person to take measurements quickly, accurately, and conveniently. The next time you pull out a tape measure, take a closer look at that curved blade. It's a reminder that some of the smartest engineering solutions aren't always complicated. Sometimes a tiny bend in the right place can completely transform how a tool works, and in the case of the tape measure, that simple curve is the reason the entire tool succeeds. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.